Hi everyone, this is my final year project entitled Image-Based Smart Lighting Simulation Tool using Cloud and Indoor Image. My name is PANG JYE WEI and my supervisor is Dr. Anusha Achutan. First of all, smart energy system is to optimize the energy consumption while guarantee the comfort level and user involvement bar interface. Smart lighting is a lighting technology designed for energy efficiency, convenience, and security. It makes adjustments based on conditions such as occupancy or daylight availability. This smart light can make decisions, follow schedule, and can be controlled by using mobile apps and voice assistant, sensing motion or condition-based if this then that technology. This research focused to review the existing smart energy approaches and propose a smart lighting solution using image of the cloud and indoor. The control system using fuzzy logic are generally fast, user-friendly, cheap, and they don't need much memory. The research problem is about the sensitivity and accuracy. For sensitivity, if the sensor is less sensitive, the light will switch off despite occupancy. And if the sensor is too sensitive, this will cause a wash energy waste. For accuracy, the sensor should smart enough to differentiate human and non-human. This is the main challenge for image-based smart lighting system. And for Wi-Fi based smart lighting system, the sensor should not include other Wi-Fi devices except the Wi-Fi connected smartphone. The objective for this research is to propose a smart lighting simulation tool using cloud and indoor image based on the fuzzy inference method. Next, to evaluate the sensitivity and accuracy in human detection of smart lighting simulations. This part is about the implementations of image-based smart lighting simulation tools. The primary platform for implementation of this paper is MATLAB. For human detection and tracking, viral zone algorithm was used for its high detection rate in real time and low false positive rate. It can distinguish the face from objects which are not face. The detector available in MATLAB has a pre-trained classifier which can identify the human face by predicting the likelihood of a region of a video frame to harbor feature of a human face. For cloud image processing, the image processing toolbox is used to analyze the image of cloud in determining the cloud density. Color thresholder apps is used to segment the cloud image by thresholding the color channel based on different color space. The segmentation was supported by 4 color space, and I just choose one which can give the best result. The image region analyzer is used to calculate the area of cloud occupied. The fuzzy inference system design has 2 inputs and 1 output. Input 1 is the indoor image, which is used to indicate the presence of occupants, while input 2 is the cloud image, which is used to capture the density of cloud. And light is the output variable in this fuzzy inference system. The table shows the fuzzy rule designs. Rule 1 to Rule 3 representing the conditions where the occupant is present, while Rule 4 to Rule 6 represent the conditions where the occupant is absent. The cloud density is categorized into 3 different classes, which is low, medium, and high. From the table, we can see that only the output for Rule 2 and Rule 3, the light is turned on. Rule 2, if the occupant is present and the cloud density is medium, the light will turn on. And Rule 3, if the occupant is present and the cloud density is high, then the light will turn on. For the other rules, if the occupant is absent and the cloud density is low, then the light will turn off. This part is about the results and evaluations for implementations. For the human detection and tracking, left side is the original image used for the testing, and right side shows the result of face detection using viral zone algorithm. From the image, we can see that the human face is outlined within a yellow box. For cloud image processing, Left side is the original cloud image used for the testing, and the middle is the cloud image after processes by the color thresholder apps. We can see that the blue color part, which representing the sky, is filled with black color. Right side is the cloud image after processes by the image reason analyzer apps. The area of the cloud is calculated here. According to the fuzzy rule base created, a simulation graph was created to determine the effect of the input parameter on the output system. The fuzzy logic graph created with the fuzzy logic toolbox surface viewer was shown in the diagram. Fuzzy rules have been calculated according to the input values defined. As shown in the figure above, an output value of 19.9 for light was obtained, for the input value of occupant is 7 and cloud is 5. Different test data was taken for the purpose to verify the fuzzy model. The result of the simulation output was shown in table. The input value of occupant that less than 5 means that the occupant is absent, and vice versa. The standard deviations of cloud is 0 for low density, 5 for medium density, and 10 for high density respectively. When the test result outputs are analyzed, we can see that the output light value of simulation 1 to simulation 4 is not exceed 10, while the output light value of simulation 5 and 6 are 20. This means that the simulation 5 and simulation 6 fulfill the requirement of this simulation tool to switch on the light. When the input value of occupants more than 5 and the input value of cloud exceed 5, the output value of light only can reach 19.9, which is the minimum value for the light to switch on. In a nutshell, image-based smart lighting simulation tool was proposed to overcome the limitations of traditional smart lighting control system. The fuzzy inference system is a suitable method to be implemented as a controller in smart lighting control technique, as it can be further developed in other automation techniques. Additional work and improvement will be required before this simulation tool can be taken into practical use. The research contribution for this paper is, it demonstrates the first use of cloud image to analyze the luminance level of indoor. For future work, Verazon algorithm shows the best result for a frontal face, rather than the face looking sideways, upward or downward. So, I would like to suggest to take the convenience of surveillance camera for the live feed of image in order to get a better result. Next, calculate the area of cloud in determining the cloud density might not accurate, as the cloud have different pattern. We have come to an end for this video. Thank you for watching.